Hi, this is the last unit of the autumn 2020 Fundamentals of Deep Learning class, and it's going to be fairly speculative. We've already talked about natural language, general language understanding, evaluation, glue and super glue, transformer architectures, language modeling. In this section, I'm interested in where we need to go in the future in natural language, and I do take the position that progress on artificial general intelligence needs to focus on language. So the question is natural language a reflection of some general knowledge representation or cognitive architecture? It's certainly what separates us from other species. And so the question is, will some transformer-like architecture ultimately be found that underlies AGI, that provides an appropriate processing and representation of language that supports general intelligence? I don't think we're there. The GPT-3 is not yet an AGI, but I do think that current progress and innovation in natural language architectures could get there before too long. However, this unit's going to be fairly speculative and just sort of give the directions that I think are promising. So when I think about language, I have this thing I like to do, which is to sample news sentences. And whenever I have discussions with people about the nature of language, I try to make my points by sampling today's news to get a fresh sentence. And here's a sentence that came up a while ago. This is not today's news. President Donald Trump on Tuesday insisted he was serious when he revealed that he had directed his administration to slow coronavirus testing in the United States, shattering the defenses of senior White House aides who argued Trump's remarks were made in jest. That's the first sentence of some article some time ago. And my point when I draw these sentences is that semantics seems to be dominantly about reference. And this is different from traditional logical approaches to semantics, which tend to be compositional. The meaning of an expression is determined by the meaning of its parts, like the way a computer program is evaluated. To apply in a function to arguments, you evaluate to get values for the arguments, then you pass them to the function. But in language, if I have a definite noun phrase like the book, what does that refer to? It's a reference, and it's highly contextual, and the meaning of that phrase involves a jump to some entity, a reference. So really, I think to represent knowledge and meaning, we need symbols, constants that represent the things that we're referring to. And we need our understanding of language to insert those symbols into the language. So let's take this sentence that I was talking about. The idea is that the phrases in this sentence are referring to things. So there's the order. The order: Trump directed his administration to reduce COVID testing. The revelation: Trump revealed the order. The claim: the order was in jest. So the idea is that you can take a sentence like this and break it down into little pieces, where each little piece is a kind of sentence that has particular entities, things that are being referred to in the sentence. And these things that are being referred to can be referred to elsewhere, later in the corpus or earlier in the corpus. Trump is referred to all over the place. So this is just more sort of filling out all of the little pieces of this sentence, how it could be represented in little statements about the entities being referred to. Now, if you were to take, let me back up. A classical approach to the semantics of natural language is to take the words of language, the verbs of language, say, and treat each one of those as some predicate symbol of first-order predicate calculus, logic. The problem is that if you take words like insisted, serious, revealed, shattered, that all occurred in the sentence I just used, these words have very subtle meaning. Insisted has all kinds of implications about, you know, saying over and over and not and resisting any attempt to undermine your statement. You know, serious, revealed. The idea is that the meaning of these sentences, if you try to force it into a Boolean representation, true, false, everything has to be true or false. That's the property of logic, of predicate calculus. Things are true or false. But in natural language, things are not true or false, and they're not even degrees of truth. They have all kinds of subtle, soft implications. So I do believe that the meanings of these words are going to require some kind of neural representation, both of the word and of these little facts that are uses of, you know, are little statements involving entities and words. So we're going to have to use some kind of neural representation. So I do believe we're going to get there by some evolution of neural architectures for processing language. I basically said what's on this slide. In contrast to Boolean semantics, the meaning of words seems to require embeddings processed by neural networks. So, you know, we have to, these constant symbols have to be embedded, and we have to build some embedding of this whole little atomic statement. A final point I want to make is that even if you're interested in real logic, you know, formal mathematics or computer code is very similar to formal mathematics. If you took the mnemonic names out of your code, or you tried to, you know, eliminate all the natural language comments, it would be completely unintelligible. So it's clear that natural language or some mnemonic, that your lexicon, that the set of concepts you have in natural language are being applied in understanding this code. So, you know, the old logic approach to the semantics of natural language is to translate natural language into logic. There's a sort of reverse way of looking at it. To understand logic, you have to have that logic tied to natural language expressions and to our natural language understanding of things. So which comes, you know, which is supporting which? And probably what's going on is there's some synergy between the two views, right? There is logical inference, and there is that logical inference is embedded in some connection to neural language processing. And that's ultimately sort of, you know, I think where we have to go. So I'll end the class there, and thanks everybody.